Okay, so let's start again. Now today, now what we're going to learn is how to set a scale bar, okay, and how to calibrate your image basically if it is not calibrated. Dror asked me one question that isn't it possible to have, because we know that the image I have acquired is from the vendor specific microscope, so can't we just drag and drop and there is no need of checking the metadata, right, whether or not it's calibrated. What happens sometimes is that the ImageJ read metadata from your file, and sometimes because of because ImageJ is a software, right, sometimes it may not be able to read all the entire metadata. So what it does is it kind of it screw up actually the metadata, and because of that your calibration will be off, will be misleading. So it's always a good idea just to check whether or not your there is a micrometer or whatever the scale that you have acquired is available instead of pixels. So this is how you should check, yeah, and ensure. So how to set a scale bar? So first, in order to set a scale bar, first we have to tell ImageJ what is your physical pixel dimension. Okay, so in order to check what pixel dimension it has, go to the image, say properties, and in properties it will tell you that it is already calibrated, right? So unit of length is micrometer, and it says 0.05 micrometer. What does it mean? It means that 0.05 micrometer belongs to 1 pixel. Physical size in 0.05 micrometer of a tissue belongs to 1 pixel. And same thing for the voxel depth, because now it's only 2D image, so it doesn't make sense. Okay. Likewise, you can also have the temporal resolution, like how many time frame interval between the two time frames. So this is how you check. But let's say that this is not calibrated. How to set a calibration? Now, because to set a calibration, of course, you go to the line tool, just draw a line, okay, and now it says its length is 6.63. I will not do it on this image because this is already calibrated. Let's go for something which is uncalibrated. That makes more sense. I mean, I could have gone, but let's go for the real example. So fluorescent cell, this one. This is not calibrated. You see here the pixels written over here? That means it's not calibrated. So to set a parameter, you just go to length and just put a length over here, and then you say analyze and say set scale. Set scale. And it automatically gives me distance in pixel, which is the 60. It will automatically copy from whatever the line that you have drawn to this window, which is a 60 pixel. And then you have to tell the FIJI that this 60 pixel belongs to how much physical distance. Okay. Now, because we know it's a nuclei. I don't know. I mean, you guys know better than me. But let's put like a 10 micrometer. Okay, of a nuclei size. And the aspect ratio is fine, but the unit has to be a micrometer. So you can put a micrometer. This is how you calibrate your image. Okay. And do not actually switch on this global, because once you put a global, whatever the image that you're going to open during this session, this setting is applicable to that image. So do not do global unless you know that in this one session you're going to work on all the images which are uncalibrated. Okay. So do not switch on this. Do not switch on this. So what I'm telling is that it's a 10 micrometer belongs to 66 pixels. So say OK. Then you go to analyze. Then say tools, scale bar. And it's going to tell me the width in micrometer, which is around 10. So I want to put it like, let's say, displaying at selection upper left. Here you can select the location in which you want to put your scale bar. So upper right, you see here, there's a scale bar over here, and you want to put how much you want to display. So I want to display, let's say 50 micrometer. Now that's a 50. So depending on you, height of the pixels, you can change that to 8, for example. That's the width of the scale bar, and the font size. Okay, 12. That you can change. Background doesn't matter. The location is important. Maybe if you're not interested in putting it in a different quadrant, but the region of your interest, then you select the location at selection. So now because we have selected this line over here, so the scale bar would come up here.
Okay.
Yes?
How do you make that scale bar
Wide?
wide?
I think side. Oh, you mean wide means the horizontal? Okay, yeah, of course. So that's the length basically. You see here? So I can go to 30. That's.
No.
Oh, you mean the
color of the scale bar. White.
Oh, wide. Okay. So just say overlay. Okay.
Okay.
So yeah. So the difference between the overlay switching on and off is that if you do not say overlay, that will be a scale bar will be a part of your image. Okay. Like for example, we are at the first channel, which is a red channel. That's why the scale bar is red.
Okay.
If you go, if you hit OK, and if you go here, OK, and then say Analyze, Tools, Scale Bar, and now it will be at Selection, Overlay. That's strange. Okay, what you do actually is just go here, Edit, Selection, say Select None. Close. Yeah, I'll just open the new one, the fluorescent cell. And I do not like this because this is a part of actually an image. So you cannot delete this. This is not overlay. This is the difference between overlay and being annotation, okay? Because this is an annotation. So if you want to remove the overlay of your image, just go to Edit, Selection, or actually the Image, Overlay, and you say Hide Overlay. Because I clicked Hide Overlay and this is not going off, it means that it is a part of this image, okay? So let's work on the image, which make more sense. So select, open samples, confocal fluorescent HeLa cell. Okay. And now what I would do actually, instead of doing in composite, I would try to make it individual one. So go to Image, Color, and then Split Channels, and I do it individually. Okay, so hit here, click Analyze, Set Scale. We already set the scale. Go to Tools, Scale Bar, and now here it's a part of green now. Okay, you just go here and change it to overlay. That would be white. But if you want to change it to different color, then you just go to Lookup Table, and then because it's a part of image, it will change accordingly. Okay, that's what it means. Yeah, and this is overlay, and when you change it, that's white. You can change it to what are the color that you want. So red, for example. Okay, so when this is switched on, you can control this color option. Okay. So let's put it more sensible, 10 micrometer. 10 micrometer, okay. This one, Analyze, Tools, Scale Bar, but not green, but the blue. This one, Tools, Scale Bar, becomes red. Now you have basically 3 images, okay? And now what you do is that what I want to do is I want to make a montage, so that in the PowerPoint or the publication or journal, you want to put it actually as a montage image with a scale bar, with a different channel that you are actually studying. So what I'm going to do is, in order to make a montage, all the images needs to be on the stack. Okay, so what is stack? But before that, I have to convert this into the RGB. Okay, so go to the image, type, and make it as RGB image. I have to cover this, that there are different types of the image available based on the pixel resolution or the pixel depth on which camera it has been taken into. So it can have 8-bit, meaning that 0 to 255 gray level can be possible for 1 pixel. 16-bit means that 0 to 65,000, 2 to the power 16, 65,000 somewhere, and 32-bit. You can also have RGB color, meaning that just the 3 color RGB, red, green, and blue. Okay, and these are just the stack. Okay, but I'm just making it RGB because that is important. So go to image, type, RGB color, this one, image, type, RGB color. Okay, and now I can go to Image, Stacks, and option Image to Stack. I have to give the name. Let's say, let's say Stack. Keep source image, so you can still, it's a good idea to check this, and then everything is there. Okay, now it's stacked. Now you just go to Image, Stack, and make a montage, and you can give different column and rows, however you wanna display. You can put it as scale bar as 0.5 or whatever the scale bar that you would are interested in, maybe 1, and then that's it. So it should work now likewise. Okay. Oh, where is the scale bar? Where is the scale bar? Why the scale bar has not appeared is because, so if you mark a montage, image, stacks, images to stack. Now there is this image, okay. Image and then stack and make a montage. Okay, I don't know why it's not appearing it. Image type, RGB, this is RGB, okay, it should work. I don't know why it's not. Stack. Somehow that is gone.
And if you put it as overlay.
Yeah, I think so. So let's go and make it as a selection. Edit, selection, and create selection. No. Show overlay. Yeah. Slice. I really don't know, man. Okay, we will cover this later because I have to figure it out why it's not doing that. Alex, what did you say?
It might be that your scale bar is overlay and it lost while.
Yeah, but I converted to RGB, so it should work because when you say RGB, it should be a part of that that image. Yeah. Okay. Okay. Or maybe let's try that because it's you may be right because it's a part of overlay, so overlay would not come up. Okay. So for that, what I would do, go to same thing. Yeah, because there was a question about this one, and that's why, because normally you always supposed to switch off the overlay because that should be a part of your image, and then it would come. Okay, now I know. So go to image, sample, go to HeLa cells. Yeah, analyze, tools, and then go to scale bar. No overlay, fine. And now you know how to change the color. Okay, so go to image, colors, split channels. Well, there is only one. Same thing, you have to do it for analyze, tools, scale bar, no overlay, fine. Analyze, tools, scale bar, make it as a blue. Okay, this one is tools, scale bar, make it as green. Yeah, and now you save this as a RGB type, RGB, RGB, go image, slice, images to stack, yes, everything is here, perfect. And then I go to image again, stack, make montage, perfect. Okay, so you have to switch off the overlay because overlay is not a part of image. So whenever you switch on the overlay, overlay will be a part of metadata. Okay, even if you save that image as a RGB. Okay, because the reason we put it here is because yeah, it was at selection mode. But this is how you do that. Okay, the scale bar. Okay, now we're gonna see how to check the brightness and the contrast settings. So go to open and let's open the sample image. Sample. Sir. Okay. You can go and to image tab and then adjust, go to the brightness and contrast. This is how you can change settings. And please remember, actually this is I was talking about that why you should be on the composite mode, because then you can control different channels just by changing this slide. You see here there is this histogram is changing, so you don't have to do it explicitly for 3 channels separately. So we are in channel number 1, which is the red channel. You can change the settings. Okay, what is this? This is basically a histogram. Okay, maybe I think before that I should cover how to check the quality of your image. Okay, so just go to sample, HeLa cell, and then if you just go to analyze and then say histogram. This is very important. This is the first thing you should check after acquisition. So go to histogram, include all 3 images. No, we want to do it one by one. Okay, so and put it on a live. So if you are in live mode, it would change accordingly whenever you change this slide, because this is a color slide. Okay, and always look at the histogram in log mode, because you remember that because you might have acquired this data into 12-bit camera, because that's why you see the maximum intensity range 4096. Okay, but as I said that the computer can only understand 8-bit and 16-bit, so that's why you see 12-bit image putting into FIJI as a 16-bit image. Okay, but still the histogram will only go up to 4095. And this clearly indicates that the channel number 1, which is the red channel, is kind of, there are some pixels which are oversaturated. And why did I concluded this? Because there are some pixels over here. You see here in the histogram, in the 4095, there are some pixels which is of which has these intensity, and that could be this one, these pixels. Okay. For what about the green channel? They are not many. What about the blue one? No, not really. So I should be very careful, and I should go back in acquisition and check the acquisition parameter for a red channel. Okay, this is how you should ensure the quality, because the pixels are saturated. And how do you see that? Because you see, just go to list, and it will tell you all the pixels which is of this count. I mean, there are 4079 intensity pixel. There are 17 of such pixels. So if you can ignore such pixel, that's fine. Otherwise, you go back and change your acquisition parameter. Okay, this is how you ensure the quality of your channels, whether or not the pixels are oversaturated. Other way, people also look as they're going for the lookup table for the different channels. So I go here, image, type, and then color and the split channels. Maybe in this case, I would go for the lookup table and I would go for the fire. And that clearly indicates that these are the region which are oversaturated, right? So I should go back and check the acquisition. Okay, that's it. How about the contrast enhancement? Open samples, HeLa cells, and just go to image, adjust brightness contrast. So as we discussed, this is a histogram for red channel, this is for green channel, and then when you are changing this knob, this is a minimum threshold and this is a maximum threshold. You are basically telling FIJI to clip the intensity between this range. Okay, So all the pixels which has value more than 1313 would be clipped off, and same thing for the minimum bar also, and accordingly it will change your data. Okay, same thing you can do it with a contrast, but what contrast does is that it stretches linearly the intensity range. This is what you're not allowed to do it. Okay, don't say apply, because when you say apply, it is going to change the raw data of your image, and you're going to leave with that. Yeah.
I mean, for visualization, I think it's okay.
Yeah.
Maybe you can actually test and measure if the true values of the pixels are actually changing. They shouldn't change, I think. I mean, this is just just for visualization.
Yeah, this is of course this is for visualization, and this is so if you
make it really strong and then still measure in the green channel one of those pixels, does it really change?
Yeah.
You don't change the values, I think.
No, the value would change for sure. Because yes, the value would change, because this is an interpolation. You see what happens actually, because when you say, let's say 550 and 1100, okay, now I am changing just the visualization. Okay, when I set and apply, what happens is that from all the pixels from 550 to 1100 will be transformed to 0 to 255 if you change this type of this image to 8-bit. Okay, let's see what happens. I say apply. You see what happens now?
But if you mouse over, if you measure a small ROI in the green area, is it really change the intensity of the pixel?
No. So for ROI, as long as you do not hit this apply button, the intensity, the pixel information is not going to change. Okay.
I think it never changes, but I may be wrong.
No. So that is allowed for the segmentation. So for segmentation, I'm making an ROI, and then when you say measure, that's fine, because you haven't hit the apply button. Okay, let's check actually this hypothesis. Okay, that's a very good question. So let's check. I go here, open sample, image, color, split channels. Let's not get confused with, maybe this one. Yeah, and I'm only interested in this one, image, adjust, contrast. If I say hit auto button, okay. So now, of course, it is just the visualization up until this point. Whenever I hit auto button, it becomes oversaturated, right? You can always reset it to the original data. But the moment you hit the apply button, you won't be able to go back to reset, okay. But let's see if I select this one and say analyze and measure. Okay, what is the value here? The value is 1523, and when I say apply, say auto, say apply, analyze, measure. You see it has changed, so the mean value. Okay, so your raw data will change, so don't hit the apply button. What is allowed is to basically use this setting for aiding your segmentation. That is possible. But once you have a mask, you always have to put that mask which you have gotten from segmentation onto the raw image. That is what one must do. Okay. So you just go here, samples again. I keep on actually closing all these things. So yeah.
But then the value wouldn't change if you did not push apply.
Yes. But it's only visual. So that's why I said you're allowed to do whatever you want to do here. Don't hit apply button, because this is for you, for the user, what he prefers to see and look at it, right? That is possible, that you can change whatever you want. That's allowed completely. What is not even that is allowed to put it on a publication, saying that this is just for visualization in order to just prove our point, but all the quantification has been done on the raw data. This is very important to note down. And also you have to tell what was your settings, because then these people are very clever, okay? So they can go back and to the metadata and they can check all these things. So don't hit this button. Okay, you can always reset it if you haven't hit this apply button. Okay, so this is all about the, setting the contrast. What else I can Then you go to image, color, make a composite. Channel tool, as I said, you can switch on, switch off, right? What else you can do? Stacks. You can make a montage. Let's go for the orthogonal view now. Let's open something, open samples and go for mitosis, just to understand the terminology of ImageJ. It is always a good practice to duplicate your image, okay? Because now we're spending time in. So go to image and say duplicate. So now it will be duplicated. Duplicates HYPERSTACK, meaning that I just want to duplicate everything here, okay? So say fine. Okay. So this is the terminology. So C channel, Z, different Z stack, and this is a time point, different time point. Okay. What if I want to crop the data? This is also important, right? Maybe if you have a big time-lapse data and you do not want to spend time on working on big time-lapse data, but you can always crop the time points. So just close it, and then you can go to image, duplicate, and here you can control. You can say FIJI, just I'm interested in only channel number 1, or maybe I'm only interested in the middle slice, which would be third one, for example. And then all the time frames, but I'm only interested in, let's say, 45 to 51. And now it would just do this. You see here? Because there was only one Z slice, there is no point in having this Z. So it's just single Z slice, but the time frame. So this is how you can actually change and crop the data accordingly. Okay, we'll just duplicate. Fine. And now you go to image, stacks. Maybe you are interested in looking at the orthogonal view. This is also possible that you can simultaneously look at the XY, YZ, and ZX plane. Okay, this is how you can see for different time point also for the different Z. Always remember in ImageJ, everything you do, it is in one stack, meaning that what I'm going to look at here, it's for channel number 1. I mean, it doesn't matter here, but it is at this Z slice for this time point. Okay, there's also possibility of doing this. This is just the visualization. Then what else? You can crop it, right? Let's say I just go select this particular section here and then go to image, go to crop. It will crop to that particular location. Okay. Yeah. Then it is also possible that you select your region of interest, okay, and you go to edit and you say clear. What will happen that whatever is region of interest, that will be black. I don't know when you have to do it, but that is possible. It is also possible to clear outside. So all the pixels which are outside this window will be blackened. Okay, and then you can only see. Maybe it is good for presentation. One must not do it in publication, yeah, but just to visualize. Okay, image, duplicate. Okay, so this is all about the stacks. As I said, duplicate, you can rename it, you can scale, you see, you can actually resize your data. Now it's 1-to-1 correspondence, but you can change it to 0.5, which would be, then it will be reduced to half. Yeah. Then rename, transform, you can rotate horizontally, vertically, different angles that you are interested in. Zoom in, overlay, that's not important. Okay, so this is all about the properties within the image tab. What else in the process? Did we cover everything? Okay, calibration. Likewise, this scale bar, one can also calibrate. Okay, now it doesn't make sense, but just open samples and again going back to our HeLa cell. You can go to analyze and calibrate histogram. Yeah, function straight line. Global calibrations. Why there is no calibration toolbar? Color, split channels, and now here, analyze, calibrate, exponential. Yeah, calibration bar I was talking about. Okay, so you can have a calibration bar over there. So you can see the intensity range within your image. So you can have a scale bar, you can also have a calibration bar. And the same thing with what we have seen in scale bar, you can actually select the region of interest in where you can put it. Okay, that's all about calibration. About the mitosis data, it is also possible that you can go to stacks. You can delete a particular stack. Let's say, for example, there is one stack which is completely out of focus, and maybe if you want to delete that particular stack, then that is possible. So the way I would do it is that I would convert it, because this is a HYPERSTACK. Okay, the meaning of stack is, remember that stack is always a two dimension. So your image and actually in 3 dimension in that way. Okay, but now because it's more than 3 dimension, that's why stack, it's called as HYPERSTACK. Anything more than 3 dimension is called as a HYPERSTACK, because we have a channel, we have a Z, and we have T. So we just go to image, go to stack, HYPERSTACK, and say stack to HYPERSTACK, stack to HYPERSTACK, and we have to tell them it's a grayscale. Now you see here that it's a channel. There are 2 channels, 5 slice, 51 frame. Okay. Is that image HYPERSTACK? Oh, HYPERSTACK to stack, sorry. Okay, and now you can see here that this is called as a stack because it's image and there is only one slide bar. That's called as a stack. But it includes all the Z stack, include all the channels and all the time frames. Okay. What I wanted to tell you is that you can add slice and you can delete slice. The delete slice would be, if you want to delete this particular slice, let's say this slice, just go stacks and delete slice. This slice will be deleted. Now it's gone off. Yeah, next slide, previous slide. Images to stack. Image, make montage, we have seen. Very important, this is project. I think I should make a copy of this. Yeah. Let's say I'm interested in image, stack, and the Z project. Okay, maybe I'm only interested in looking at the maximum intensity projection. I'm not interested in basically all the Z stack, but only the one Z stack, but that has to be maximum intensity projection. How do I do that? Go to the stacks, Z project, and then I'm telling that I have 1 to 5 slice, make it as a 1 slice based on maximum intensity. So everyone know what is maximum intensity. It goes through each and every pixel over all the slices and only pick up the pixel which has the maximum intensity. And thereby you just have a 1 Z slice. And it is asking for all time frame? Yes. Okay, so before I do this, it's better I just make a copy of this so that I don't have to save as and go to TIFF. And I put it on desktop. Okay, now it's here. So that's good. So just go to stacks, Z project. Z project and say maximum intensity. Now you see here, the Z slide bar has gone. It's only the maximum intensity projection now for all time frame and the different channels. So you can actually go and say color and then split channels. So now you have the time points for every different this one. Okay. this is all about the visualization thing. Duplicate this. Yes. What else you can do in the stacks? You can go to stacks, montage, set project. Plot z-axis profile. This is also important because if you want to see the intensity of your region of interest or overall image over time, then you can also do this. So just go to OK, and now this is showing me the x-axis is time and the y-axis is the mean intensity of the entire image. Okay, but if you are now interested in only the particular region of interest, then you can just say click here and go to the live. Now it has changed. Okay, and when you go here, it is going to show me this vertical slide. So this is the intensity, mean intensity of that particular region for channel number 1. Okay, because now this slide is at the red channel, so this is only showing the red channel. Now if you put this here, this is for green channel for this particular region of interest, right? So maybe this is interesting for if you just want to see the degradation or the FRAP kind of analysis, what is happening.
Can you show again what it was, this option?
Yeah, so just go here and maybe let's say I'm interested in, let's say zoom in. I'm interested in knowing what happened to this particular, this particular region. Okay, so you just go here, I draw this region, and from the beginning to end I can actually map this. And how do we do this? Just go close it, go to image, stacks, and then plot z-axis profile, and it is asking me for time. Yes, okay, go to live, and then you can change it actually, and it's live. It would tell me the mean intensity over time and also this thing. Okay, close it. What else I can do? I can just go to image, stacks, set project, set axis, 3D project. I'm not going to go into detail because it will just show me the 3D project. Okay, you see here, it's kind of Imaris way of looking at the data. Okay, so because there is no Z, but it's taking it's kind of a volume rendering actually in Fiji, but it is not as good as other commercial software. That's kind of a big drawback of working on the 3D data. Okay, so this is all about this one. Then duplicate, transform, stacks, label, statistics, tools. Yeah, by the way, you can also combine two different stacks. Okay, so if you go here, image, color, split channels, and then if you just go here, stacks, tools, stacks, tools, combine. I want to combine it vertically. No, not really combine. You see here now? Okay. What else? Adjust threshold. Okay, let's go for the thresholding. Okay, now it's time to go for that. So this one, allow set measurement, child tools. I'm just looking at what is left actually. Edit, we have covered everything here actually. Cut, copy, draw. Oh yeah, actually I haven't told you how to draw and other things. So it is possible actually, because this is a kind of overlay now, this is selection, but it is possible to make that as a part of an image. And how to do that? You just go to edit and you say draw. Now it's a part of that particular image. How to change the color for that? You just click here, and then this is a foreground color and this is a background color. Okay, foreground color is this one. This is how you change it. It is also possible to actually fill up the region of interest. So maybe if I just want to fill a different color, edit, and you say fill. Now it will be filled. Okay. That's it. You can make a text actually. Just put a text over here. See, you can change the color of this text. That is also possible into the advanced level. Color, crop, duplicate, rename. That's fine. Process. Okay, let's quickly see the pre-processing, the processing of an image. Sample. Go to let's say go for fly reinforcements. Cell again, and then I'm going to split channels, and let's work on only one channel. That would be easy for understanding. You can smooth it, right? So smoothing is just making it more blurry, kind of, right? And you can do it multiple times. So Control Shift S, Control Shift S, and if you keep on pressing, then it becomes blurry, right? See here now. So please remember, you are allowed again the same discussion, to do all these things in order to aid your segmentation, in order to just make your mask, and you have to put that mask on the raw data again. Yeah. I'm also going to save this, save as to TIFF, HeLa cells. Okay. Image, color, split channels, off, off. Okay. You can make it sharp. Sharp is nothing but high pass frequency. I mean the high pass filter, right? So it will allow only the high frequency component, and it will reduce the low frequency component. Find edges. This is a kind of an algorithm which you can apply. See here, that's finding an edges. There are different types of algorithm for finding an edges. Yeah, the canny edge detection, the Sobel and the Previtt and other things. But I will cover it, how to use it and when to use it, right? Okay, in advanced level training. So process, sharpen, find edges, find maxima. That's also possible. So let's open some image. Open here and just go to C-type, FIJI. Workshop, demo images, and the white field, the segmentation, and the cell or the nuclei. Okay. I will save this again. Save it to TIFF as a part of this one. Okay. Process, find maxima. That's very important, especially if you have a foci-like image and then you want to quantify how many foci are there, or like for example in this case how many nuclei are there. Just go to process, find maxima, just go here and you say preview, point selection, exclude H maxima, and then you say you want to go for the segmented particle. Why is not displaying this? It's because maxima within the tolerance, go for 400. Yeah, This is what it's, so it's segmented, see? That's like a maxima. Using this image, when you put that particular settings, it automatically segments based on your maxima. Okay, that's also possible. Process, find image, enhance contrast. Did we see this? So it is also possible that you can clip 0.3% of your intensity range from minimum to maximum from your data. Again, it's very important. This is not allowed to change your raw data. This is only we are doing it just to do segmentation. Same thing with the normalization and histogram equalization. It's just the image enhancement procedure, okay, algorithms. By the way, I have just covered everything here. So if you just go to image restoration, there is this link available, okay, in this the whole platform. You can see this image and data analysis related things, seminar on image processing and segmentation. So you will see all the explanation about all the image processing and segmentation algorithms. So do not do this, only do it for making a mask. Okay. Process FFT, maybe this is important, that if you want to do some kind of frequency domain filtering, let's look at it actually, not with this data, but maybe with this makes sense. So if you go to, where's this, Lida, and make this image type to 6-bit, which is a grayscale now. Now it's not RGB, but now if you just go to process, FFT, I'm just making it actually the Fourier transform. So the Fourier transform of an image is like this. So this is a spatial domain. So whenever our eyes look at the data or whatever the natural scene, that's in spatial domain, and this is in frequency domain. And this center part is a low frequency, and as you go away from the center, it becomes high frequency. Okay. So what I do now, I try to do, let's build a bandpass filter. So what I'm going to do is I want to clip the low frequency component, and I want to only retain the high frequency component. How do I do this? Just click here, over here. I want to clip this part, okay? So just go to edit and you say clear. I'll just go back to process, FFT, and now I want to actually see what is the effect of this in frequency domain to the spatial domain. So inverse FFT. See the effect now? So because we have done this filtering, this is the, and you remember now, because we have only allowed the high frequency to come up. This is why, because all the age-like structures, they are retained. And this is what it means actually in frequency domain, the high frequency component. So it is important if you want to do this. Let's say, let's go to the practical example, maybe again the HeLa cells. And in HeLa cells, you want to make a nice mask actually. So color, split channels. Maybe you want to actually interested in looking at the high frequency component. Process, FFT, do the same thing actually here. Edit, clear, go here, process, FFT, inverse FFT. See the effect? And you can make a mask actually out of this one and then put that mask on the raw image to just quantify the fiber-like structures. Okay. Actually, it's very important in the structure illumination microscopy, STI. So, okay, you can do actually reverse. So let's see what is the effect of doing reverse. So close this, no, close this one also, and I'm making it process, FFT, and now what I do is I make this ROI. But I make this ROI here, but instead of clipping this part, I clip everything else. So edit and I say clear outside. So I'm just retaining the low frequency component. This is only low frequency component. And see what happens actually. Process, FFT, inverse FFT. See now? So this is the low frequency component, okay, of this image. The age has been, so this is basically nothing but doing this Gaussian convolution. That what we have done here, process and smoothing multiple times. You would get the same thing actually here. Okay, so this is all about the pre-processing in both spatial domain and the frequency domain. It is also possible to make a binary, the arithmetic calculation over two images. So if we go to HeLa cell again, color, split channels, close it, and let's say I want to make a one combined image out of these two. So just go to process, image calculator, and you can do all these operations on these two images. So let's say multiply or subtract, for example. See what happens. Well, everything will be subtracted, right? Because it has to be in 32-bit. Yeah. So if you just go to process, again, image calculator, float. If you just go process. Yeah, there is one pixel over here. Oh, that's gone. Process, image calculator, create, maybe add actually. Let's see what happens to that. You see here now? It's added. That's because we haven't selected actually. We haven't selected the proper image calculator, and here because we are selecting the same image, we should select this one. Okay, and then you do whatever you want to do. Subtract. Okay, and now this is what you see. You can change the lookup table because this may not look okay. So just to put it gray. So now you can see actually what's happening simultaneously. So likewise, you can do all the arithmetic calculations. Okay. This is all about this one. Also, there are some filters that you can do explicitly apart from this one. They are also kind of filters, but extra filter like in 3D, you can do all these things. So if you have a 3D data, Z-stack, you can do Gaussian blurring in 3D in FIJI. It wasn't available in ImageJ. This is the beauty of FIJI actually. You can do all kind of median and other mean filtering in 3D. You can convolve, and then you can actually write your kernel, which is a bit advanced, but that is covered actually in this one here. I have explained what it means actually. So there are many ways you can actually do segmentation, not based on threshold, because threshold is just one way of doing it. We haven't seen it, but let's look at it now. But before you do thresholding, you can pre-process your image in order to make it your thresholding as easy as possible. Okay? Because if you just have a nuclei, then it is not a big deal to segment the nuclei. But let's say if I'm only interested in this particular maximas, these particular spots, then it becomes difficult just by thresholding, and then we will see how. So if you just, let's say this is my image, go to process, image, adjust, and say threshold. Now thresholding, as everyone knows, what I'm telling now to the computer is that I want all the pixels whose intensities is more than 739 until 4095. You can change this one also. See what's changing here? And it's a dark background, right? And most of the fluorescence, they're dark background, right? Unless this is DIC, then you might want to switch off this, and then it becomes the white background. Okay. But when you say hit apply here, then it will create as a mask. You see here now? And then you can put this mask on your raw data and then analyze your data. So this is basically segmentation. But my point was that before you come to this thresholding, make sure that your quality of your image is sufficient enough to segment and threshold your data. Let's go for nuclei here. You also might want to consider the background subtraction, okay? And the way you do is just go to process and subtract background. Now, what is this rolling ball radius? I have explained extensively how this rolling ball algorithm works actually, and this is very useful, especially for Imaris and all kind of segmentation. I mean, we use a lot. So there is a preview thing here, and then you can see the effect of changing this rolling ball radius. Let's go into 100. If I make it like very small too, you see the effect of changing this data. So it depends, what do you want? So for example, if this had been a foci-like structure, I would go for rolling ball radius not more than 10, and then it would actually pop up the foci. And then that would be easy to do a threshold width segmentation. Okay, same thing with this light background. This is useful when you have a DIC kind of images. So adjust, go to threshold. There are different algorithms by which you can find this thresholding. Okay, so one which is very famous is the Otsu, and this is what by default, when it is on default mode, this is what it will calculate. Okay, so if this had been a Z stack, then you can actually check in this. So stack histogram, meaning that this threshold will be applicable, and this threshold will be computed based on all the Z stacks. So in our case, it doesn't make sense. So see the effect of thresholding? No? Because if I select everything, then everything will be selected. So it doesn't make sense. So I'll go for this one. Okay. Then I say apply. But now see the problem. The problem is that these are two nuclei, but because of the threshold was not good enough, it has become 1. And how to deal with that? Then we have to go to the watershed. So apply, go here, process, binary, and now because this is my binary image, okay, so go to binary, then go to watershed, and the watershed has been performed, and now you can see actually they are very well separated, which they wasn't. Yes.
If you have several images that you want to compare,
yeah,
and you go to threshold, then he will set an automatic threshold for each individual image.
yes.
Would you say this is the most appropriate way to do it, or would you set a manual threshold that is the same for every image that you want to compare?
I get that question a lot, especially for high content screening also, because then once you set a one threshold, that should be applicable for both of the group, right? The control and the experiment. But it is allowed to do segmentation separately, segmentation parameters separately for two different conditions, as long as you are blinded to the conditions. So meaning that I can have this auto thresholding for every images, because every images are different. Maybe the acquisition conditions were different. So as long as you do not tell your algorithm that this is my control experiment and do this thresholding because I know the output, that is something is not allowed. But that is allowed to have a different settings for different images and different conditions. Because ultimate goal of segmentation is to come up with a mask which has a biological meaning, right? And if you apply the same auto thresholding for other condition, which completely messed up, right? Then it doesn't make sense to get a quantification from that, just to follow the rules. It's not good, right? So it is okay to have it, but make it blinded. Should not be aware. Okay, so this is how it has done this watershed segmentation. Again, to understand how the watershed works, again go back to this slides. I have very well explained it. Okay, so we have just 30 minutes or 45 minutes left. So this is all about the segmentation, and then quickly we will just make a break before we. So after I explain you how to quantify. Okay, so let's go. So once I have segmented now the nuclei, then go to analyze, go to measure. When you hit a measure, see that's a problem. So it's just giving me the one area, which is the sum of all the areas of this nuclei. But what I want is that I want the individual nuclei areas, and for that, just close it. Go to analyze, and then say analyze particles. And in analyze particle, it is also possible that I can filter out the nuclei which is not of my interest, which doesn't make sense. So I'll just zoom out a little bit. Okay, maybe I'm not interested in the nuclei which are at the boundary, which are because they are incomplete. So I just go to analyze particle, and here maybe I do not want nuclei which is of very small size. Let's say here they're very small size. So maybe I want the nuclei which is of 100. And circularity, maybe I'm interested in knowing the morphology or the shape of, I want to filter based on the shape of the nuclei. So 0.5 maybe, or 0.2 should be okay, because not all the time they will be circular, right? But I do not want anything which is completely awkward, right? So that's why I say show, and then I show, say, outline. Display result, I want to display the result, clear result, meaning that if you're doing this process multiple times, there will be a window open for the previous measurement. Then that will clear off every time you hit this button. Add to manager, I will come to this point, but then exclude edges, meaning that you exclude all the nuclei which are at the edges. Include holes, no, and we hit sit, okay. Now you see all the nuclei has been counted now, and it is going to give me all this information. So there are basically 387 nuclei. Okay, and this is all the individual information features about every nuclei. This is the area, this is a mean intensity. Now you see what happens is the mean intensity is 255 because we have worked on the masked image. Okay, now how to get the raw data information out of this one? So just close this. Okay, again close everything, close this. And then how to get rid of this? Just go here, edit, selection, and select none. Overlay. Manager. Okay. That's off now. And then you just go here, analyze. Before that, you have to open your raw data. So just go and what was my nuclei? Just open my nuclei here. So you see the difference between the raw data and, difference between the raw data and my mask. Okay, so I'm allowed to do whatever I want to do here. That's fine. Then I go to analyze particle. Not here actually. Analyze, set measurement. Okay, in the set measurement, you have to, you can tell what kind of features that I want to extract. And so this area, standard deviation, mean gray intensity, but here there is this selection on which you want to apply. So I want to apply it on the nuclei 1 def. That's my raw data, right? And that's it. So you just say hit OK. And now you go back again, go to analyze particles, and now all the information that you're going to extract is based on the intensity. You see here now, every nuclei has got an intensity from the raw data. Okay. Is everything clear now? How to make an overlay? So just say show. Now you can see here on the raw data itself. This is my raw data. And this is the outline of the segmented nuclei. Okay, and it's going to give me the numbers also. So I can switch on, switch off, switch on different ROIs. Maybe I'm interested actually in applying this ROI on different channels. That is also possible. You just select a particular image and just hit this button and just say show all. It will be displayed, your ROI will be displayed and transformed to the other image as long as they have the same physical dimension. Okay, this is useful when you do a multiple segmentation. Let's say I segmented cytoplasm, I segmented nuclei, and then I segmented entire cell. So there are basically 3 overlays or 3 masks, and you want to simultaneously put that 3 masks onto the raw data, then that is possible using this one. Yeah.
Can you show again, please, how you
yeah.
use the ROI from the analysis?
Okay, let's go back. So this until this point is okay. I close ROI now. Sorry, ROI manager, everything is closed, discard. Okay. Now this is what I have segmented, right? Then analyze. Before you analyze particle, you should make sure that your measurement is set properly. Okay, and then here, if you just go again, cancel, analyze particle, set measurement. In set measurement, you can select which feature you want to extract, and also on which you want to extract. Because shape information has nothing to do with the raw data, right? It is based on only the binary images. But for example, the mean gray value, it needs to know what is the raw data, and that raw data you're telling that raw data take it from here, which is nuclear.tif, which is my original image. Now it is not open, and so I will just close it. I will open that first. Now go back, analyze, set measurement, and what is the name of that? That's the nuclei1 TIFF. Okay, because the name of the segmentation is different. It's a nuclear.tif only, and the original raw data is nuclei1.tif. So I'm telling that, take it from there. So okay, and just go to analyze particles. Yeah, and here you can do the same thing. Oops, shoulder. Yeah, the reason why it may not work is because then you have to go click here, highlight this, go to image, actually the process, and make it binary. Okay, make as a binary, then it will work. Analyze particle, set measurements, nuclei1.tif. Okay. Much well. Okay. And then if you just close this, select this. These are the different region of interest, by the way. Okay. These are different nuclei. You can name them, but of course, if it is a nuclei, then you don't want to name them. But imagine that you have just 2-3 segmentation object in your interest. Then you can actually rename it individually. You can name them accordingly. That's possible. You can save this because that's important, right? So you just go to more, and then you can save this ROI. Just put it here. Is it all? I have just deselected. Oh, okay, because I have selected only this one. So let's say measure, deselect everything. Okay, and then you just go more, save, ROI set. Everything will be, this is ROI set now. And then if I just close everything, discard, open this nuclei, analyze, go to tools, ROI manager, and now here I open it. Open, go to this ROI set, and I say show all. Now it's displayed. So you can open any image and apply that ROI on that image just to see what is happening. Okay. This is if you want to save this for publication, of course, then just go here, file, save as, make it as PNG. Okay. Yes.
Can you manually add stuff in there?
Yes. Yeah. You can. So you just go here. Let's say, imagine this is a nuclei which you wanted to segment, but you couldn't. So just select this and then say add it. Now it is added. And it should add actually somewhere. That is added. You see here? Okay. And then you come to know how many nuclei are there, what is the intensity of different channels within the nuclei, and also the outside. How to change this mask, that's also important. So let's say I am interested in, I will open this one image. Should we take a break, a short break, or 5 minutes, or should I carry on? Because I just have to cover now the co-localization, and I think it should be done. And I will just show you the advanced image segmentation way of doing this in Rica, machine learning based. Should I carry on? Okay. What I wanted to show you is this C drive. Go to FIJI workshop. demo image, white field, segmentation, and this. So you see here, let's say if you have this example where you have the nuclei also and the cytoplasm also, and maybe you are interested in segmenting the entire cell, then that is possible. So, and now for example, in this case, if I use the thresholding, let's say adjust thresholding, this is a bit difficult, right? Because it is not good in contrast. Well, it is good, but my point was that there will be some situation where this thresholding won't work. Then you might have to consider, doing some pre-process, which we did actually before. You can also go process and say find maxima. Just go for review, single points, 7 maximas. Change this to 10. See, these are the maxima that's coming up. Not light background, that was my problem. So now it's coming, okay? So if you are only interested in knowing how many nuclei are there in such a corrupted, not I would say corrupted, but with a low contrast image, then one should go for find maxima. If you're only interested to know how many nuclei are there, okay, or how many cells are there in this case, so one can go for this. Okay. See, this is a point, and then you can actually go to analyze and do the same thing, analyze particle, okay, to know how many nuclei are there. I think this would work best for the foci detection. Okay. Properties, HYPERSTACK, duplicate, zoom, overlay. One thing I haven't showed you is plugins, 3Ds. Oh, 3D viewer. Okay, let's go for the 3D. Actually, we haven't checked that. So go for mitosis. And then there is a plugin if you're interested in looking at the 3D, for 3D view. Of course, it's not as fast as Imaris, but you can actually do many things. See here now? Not bad, right? And this is the time point, time lapse. So it's not that interactive, okay? Of course it is, yeah, it's very premature in that way. But at least you are able to see what is there in your data set, at least at your computer, if the Imaris is busy. So at least you should check what is happening. What you can do is, if you just quickly, yeah, exactly, because it needs a lot of graphics power, yeah. You can actually make an animation. Just let's make a small animation. Let's say just add here, landmark view, and the start freehand recording. Click here, and then just change it to zoom it a little bit. I would make it like zoom. This one, and then go back again. Say view and stop freehand recording. So you can make actually the movie out of this. You can also record from here. But I would advise you to go to Imaris to have the animation. Okay. So this is the movie which was calculated. You see, this is a movie. The reason why it was clipped is because it has to be on the full view mode, okay? Because we actually cropped it. But it is possible to actually have the animation in FIJI. And also you can view and visualize the data. What else? FIJI, patch, processing, subtract, repeat commands, smooth. Properties, color. We have covered everything, right? The noise, you can add noise, you can despeckle. Let's say if there are a lot of speckles noise, like speckle is nothing but the high frequency component, like dots, no, so many dots, and you can actually filter out that. This is also kind of a frequency domain filtering, but there is one way. It's this shadow noise, and you can say despeckle. So inside despeckle, the algorithm will work, and you see here despeckle. But again, it is not allowed to read on raw data. Okay, just do it for segmentation thing. Okay, what's that? Tosses. Stack. What else? Analyze, label, set. Spot tools. I think we have covered everything now, and then set measurements, distributions. Good. Plugins. I just quickly want to show you this the bleaching correction, and if you want to quantify what is happening. So just give me 2 minutes. I'll just go through the notes and see what is remaining. We have done this. Automatic ROI. Vibration. Okay, let's go for one thing I haven't told you is that one can do also the deconvolution, the color deconvolution. That's also possible. You can simulate to the color blindness people. So maybe some of the journals they might want this because they want to have a color image to be displayed as the color blindness image. So that is also possible to have it. Image crop duplicate. Process contrast. Yeah, the color thresholding, that's important. Okay, so because so far what we have seen is just the grayscale thresholding, just only one channel at a time. There is also possibility of having doing thresholding in the color mode. So how do you do that? You just go to image, adjust, and then this color threshold. There is 2 ways. There are different color space, right? Again, I have actually covered in this PDF. We are interested in RGB color mode. Okay, RGB color mode. Switch off, and sometime it works, sometime it doesn't work. Okay, because it's bit it's a advanced level. So sometimes you just have to switch off your FIJI and open it again, and then so it's not that stable. You see. So maybe make this showing image, make it as RGB, click off, go image, color, adjust, color threshold, now it works. So the reason why it didn't work is because our image was in a composite mode. Make it composite to RGB, and then you can apply this color thresholding on this. So it HSB to RGB. And now you see what happens. So maybe I'm interested in segmenting dark background, B, default. You see here? So I can only control one particular channel at a time in order to do a segmentation. So here. Select. So this is how it is segmented. Now you switch off, go to the other one, and now you can do the segmentation likewise here. For green, you can select, switch on, switch off. That's for red one, right? And then so select. So now you have everything on actually. And then you can go to analyze particle, and then you say set measurement, and you say limit to threshold. Switch on this limit to threshold, because now I want to quantify all this measurement limited to this threshold. This is what it means. Okay, and then you go to analyze measurement. It's here. Well, see, okay. It's all the nucleus. There are 5 nucleus. I mean, of course, you can get rid of this one just by again going back, analyze, and then analyze particle, and you say that you do not want the smaller one, so 100, and see clear display result. Oh, because it's a drawing, right? It's not a pure picture. So this one you can get rid of based on from the beginning itself. Discard it. Just go here, analyze it, analyze particle. A particle will be detected because the size was too big. But you understand, right? You can filter out based on the size. Yeah, you can completely get rid of this guy over here. Okay, so this one can also do segmentation in the color mode, RGB. Similarly, you can do the same thing, quantification for the red channel, and then so the green one here, this channel, and the red one here. Okay, how about the co-localization? Let's go for co-localization. Okay, that's important. So for co-localization, again, I'm going to go to the HeLa cell, and maybe it's very stupid to do that, but just to understand, just for illustration, I'm going to go to color, split channels, and I'm going to delete this. And my interest is to know if this red bodies are co-localizing with the green one. Yeah, I can see clearly they are not co-localizing, but let's look at it, right? Just check it. One can do, one can segment this particular region of interest, another region of interest, go to the ROI manager and do the logical AND operation and see the area of interest. That is also possible. Okay, but because we do not have time, but that should be easy. So do you want me to do that quickly so that we can also learn how to do segmentation? So go to the process, image, threshold, go to threshold. That's fine. Good. Dark background. Then you just go to analyze, tools, ROI manager, you just add it. Oh, active image does not have the segmentation. Why is that? Okay. Say light and go to ROI manager. Active image does not have a selection. Okay, because selection mode. Selection, add it. Okay, because it was binary image and it was not selected, so go to edit, selection, create selection from your binary mask, and then you add it to your region of interest manager. Similarly, you have to do the same thing here. So say, okay, maybe it's here. Apply, go to edit, selection, create selection, go to ROI manager, just add it. So now you have 2 ROIs, okay? So what I would do now, I would just close this, open HeLa cell again, and then I highlight this, make it as an RGB, and now it is displayed. I can select which one I want to display, or you can say show all. Okay, The point is that I can also create, so I can select two region of interest, go to more, and I say AND operation. This is a co-localization basically, right? Co-localization based on area. So if I want to know how much area is co-localized in these two channels, then that's possible. So say AND operation, and then go to, yeah, measure, right? So now there is this AND operation. Yeah, and update it, but there is a possibility of doing that. Okay, so select this one, more and operations, go to analyze and measure. That's the third one. So you see area now 21. Okay, so the area of the first channel was 45, 123, and now the overall area of co-localized one is 21. Yeah, you just you go here more and say AND, okay, and now you just go to analyze, because that will be highlighted actually. That will be an ROI there, which would be selected, active ROI.
And can you edit as a new ROI?
New ROI, oh, that's good. I don't think so.
If you add.
Oh, you want to make it as actually the new ROI, right? Yeah, I understand your point. Yeah. I mean, it should be able to. I don't know. It's just a limitation, because I put ROI and then it's not coming up. So I don't think so. Oh yeah, that's true. Yeah, that's good actually. Yes, could be. Let's say add. Yes. Yes. This is all. You sure?
You need to do the AND operation first and then press add.
Yeah, but we did that, right? Isn't it?
I think you selected one.
Okay, so I just delete this now. Delete. Go here. Control. More and then say add it. Yeah, you're right. This one. Yes. Yeah. Okay. But this is very crude way of just quantifying the co-localization. What I would always prefer is the co-localization module, right? Because then I'm also not interested in the area of co-localization, but also interested in Manders M1 and M2 statistics. So close this, and image, color, split channels. Go there. I remove this region of interest. So go to image, overlay, remove overlay. Go to plugins, and in the plugins, there are so many things actually in ImageJ, and then you might get confused that where is what. In that case, say Control L, and you can search your keyword. Let's say co-localization, and it's gonna give me its location where they are, and it is possible to just double click and run this particular command. So co-loc 2, let's go for this, or co-localization threshold. Let's go for this one, run. It's asking me what is your red channel, which is my C1. It's a C2, my green channel. Do you have any ROI? It is also possible to only find the co-localization within the region of interest. That's also possible if we had the third channel. Show co-localization pixel map, everything, all this parameters show also scatter plot, because just by looking at the scatter plot, one should be able to know if they are co-localized or not. And say, okay, now it does something. Co-localization, this is a scatter plot. Just by looking at scatter plot, I would say they are not co-localized, because to have a good co-localization, it needs to be linear, right? And now it's kind of a anti-co-localized, kind of anti-correlated. So let's see what the result shows. So result says that, so percentage of co-localization threshold, okay, where is my estimate? R-colloc, okay? So 0.5. That's the correlation coefficient, Pearson's correlation coefficient. It's 0.5, so 0.5 is not good because the 0.5 to the power square, I mean 0.5 square is less even, so that's not a good co-localization, I would say. Okay, so I have covered the entire co-localization thing and all the issues related to co-localization, how to interpret the Manders M1 and M2, how to do thresholding, how to decide, because if you do not mention what is your background pixels, then everything will be co-localized. So one needs to know what is your foreground, needs to know what is background, and then you co-localize it. Okay. So it's all about that. It's all co-localization. We still have 15 minutes actually. So let me check. Oh, we haven't actually covered this machine learning based image segmentation. So quickly, if we have time, we can just do this. So I open. Sometimes it is not possible to do a segmentation, accurate segmentation. So we have to train our computer that I'm interested in. I will just show you how. Image, type RGB, close it, and then go to plugin. And then again, if I'm lost somewhere, I can just say Control L and then look for Rica segmentation. But now you see here, now this in the segmentation tab within the plugin, there are these many plugins are available in order to segment your image. And which one is the best? Of course, it depends on the data. See, it's not like Imaris, you just hit the button and you get the result. So you have to see, depending on your data. So trainable Rica segmentation. This is a bit popular actually. That's why I'm going for this. Trainable Rica population. Okay, and this will be shown actually. So it says train your classifier, but you have to add the classes, the class labels. So for example, my interest is to basically segment this entire image into 3 classes. One is for nuclei, another is for red and green. So I would select this region like that and say add to class 1 and this one. I'm just doing very stupid thing, okay? So green one, and then maybe create new class. You can actually rename it also. Class 3. Okay, and then I say green one here. Just class 3. You say train classifier. Sometimes it just gives a rubbish result. So you have to be very specific about what you're doing. But just for illustration, this should be enough. So I'm telling computer these many sets of pixels are there, which belongs to one class. Likewise for 3 classes, and just asking computer to do it. And now it's doing this all exhaustive machine learning stuff. So it's training a model. But this is a one-time procedure. So once your model is built, you can save that model and then you can let it apply for a bunch of images. That way it's fast. So I don't know if my laptop is dying. But should okay. Do you agree? Well, not bad actually. At least the nuclei segmented nicely. That's the red part, right? It's the red part here. The green one is the other channel, and the magenta is this one here. Not really, because we haven't actually selected a proper region of interest. It is also possible to have a multiple region of interest because one is, yes.
So normally when you do machine learning, you want to have many training examples.
Yes, yeah.
The more the better. Is it enough just to make?
No, that's why I said it's just for illustration. For machine learning, the sample size is it's like a curse of dimensionality, right? So it is very important to have a multiple training points and not also one image, but I would go for multiple images. Yeah, because, I mean, computer cannot be clever than you, right? I mean, you have to train unless you train them properly with the deep learning and other things. But the theory behind this one is a supervised machine learning. So it is not that fancy of deep learning and things like that, but one can actually, I wouldn't be surprised if there is a plugin in future which would say deep machine learning based image segmentation. Okay, but this is how you can do it. So you can have multiple ROIs belonging to one class, right? Class 1, vector class, likewise, okay, and then it will be more accurate. Okay, you can save this classifier and then let it apply for the other one. That's possible. What is left? Let me check plugins, skeletons, stacks, stitching. I will cover the stitching and the tracking in the advanced level. Okay. One thing I didn't cover is the drift correction. It is also possible what we do in MRS. It is also possible to have a drift correction. If you have a time-lapse data and if your stage is moving, then it is possible to have a drift correction. So just quickly I can show you, you just go here, there is also a plugin there. Look for registration. In the registration you can go for stack registration. Okay. Yeah, there is a different algorithm for this. You can apply, and it will take time because registration is an optimization problem. So it will try to find the principal component which would correct your movement from one time frame to another time frame. Okay. That is also possible. I'm not going to spend time on this. Plugin, stitching, time lapse. Yeah. Volume viewer, did we see this volume viewer? Yeah, we saw it, right? Yeah, I would prefer MRS one than this. So I'll just close it. What else? Tools. Unless there is a specific question, I don't know. Yes, go ahead.
Can you comment a little bit more about the options that you can choose when you say set measurements?
Yeah.
So for example, if I have done this analyze particles and I want to see like how bright the individual particles are, would you advise to go for mean intensity or median intensity? So what are the benefits or pitfalls?
Yeah, exactly. So for the bright object, of course, in brief, I would go for maximum intensities. Okay, but again, when I say bright, then maximum intensity is nothing but just the maximum. If there is a 1 pixel, which is just the maximum intensity within the region of interest, then that will completely falsify your hypothesis. So in that case, I would go for integrated intensity. Okay, because it's here, the integrated density, which is yeah, that's basically the sum of all the intensities, sum of all the pixels.
So that means the bigger nuclei.
Yeah. So we are not normalizing based on the size of the nuclei, because when we calculate mean, what happens actually? It's all the sum of all the intensity divided by how many such pixels are there, meaning that it's how big is the object, right? Let's say if you are going for, if you want to segregate the G1 phase and G2 phase, let's say of the nuclei of the cell cycle, then I would go for some intensity, okay? Because in some intensity, you clearly see the first peak, which is for G1, and then S phase, and then G2 phase, right? I would not go for mean intensity. But of course, then if you want to look at in 2 dimensions, then I would go for x-axis as a total intensity, y-axis as a mean intensity, and then I would see 2 clusters for G1 and G2 phase. But this is unfortunately not possible in FIJI. For that, we have the dedicated software like Scanner, which is specifically for, in order to, you can have a different gates and you can have a subpopulations based on the life cycle. I understand your point that because in FIJI, we are kind of limited to these many features, right? What if I'm interested in some other advanced feature, but then for that, we have to have a plugin and the macros, which we're going to cover in the next session, okay? What I haven't covered today is how to write a macro. So what we have done so far is just importing one image, doing some processing, doing some segmentation, but this is just for one image. one can write a macro on this. So one can just go to plugin, go here, macro, and one can record it actually. So whatever you do here, that will be recorded here, and you can save that as a macro, and then you can apply that macro for all other list of images, like a batch processing. That's possible, and we will cover this in next class or next workshop. Okay. Yeah, that's it actually. We haven't covered this extended depth of focus example. So maybe we just have 5 minutes. What happens normally when you take a live cell imaging for longer time lapse, and if you do not have a confocal imaging, but you have a wide field, then some of the cells are out of focus. Now, what you can do traditionally and then just roughly is that you can always go for the maximum intensity projection of all the time points. But that is not a good idea, smart way, because at some time point, one of the Z slice, the cells are in focus. In another time frame, the Z slice has been changed, right? So it cannot smartly go to individual time point and look for the Z slice which is in focus. Okay. In that case, there is a plugin called as extended focus process, and this extended depth of field. Okay, I don't know if we have time now, but I could have shown you quickly, but I think it's better if I explain you next time. So if you have an image like this one, open segmentation, fish. This one, you can see here. See, it's out of focus, right? At some time point. So this time point is okay. This time point is fine. At this time point, it's blurred, right? It's out of focus. So how to correct for this? So that is possible using the extended, depth of focus. Again, there are different settings for that. It's not that straightforward. You just click the button. There are some different 4 algorithms for that. Okay, so we will cover that all in the next workshop. Yeah. Oh, by the way, you can actually have just quickly, because just 5 minutes. Open. You can do some kind of a frap or decay curve fitting. So go for the, where was it? The calcium thing. Confocal. See here now. This is the time-lapse data, and now people are interested in just knowing this influx of calcium or whatever. I mean, you guys know better than me, but what point is that if you have the region of interest here, you can quantify that data and then fit a curve of recovery or decay, both. Especially for this the cyclene B1 degradation. So you can segment first the cytoplasm, you segment the nuclei, and then you track the cytoplasm or the nucleus over time. Then just before the mitosis, the B1 influx would be there in the nucleus. So that you can do it actually over time.
That's something you're going to show us next time?
Next time, yes. Yeah. So just send me an email if you have a specific application that you want me to cover, because you see plugins, if I want to cover it in one go, it would be difficult. So if you have a specific application, just let me know, and then I will prepare data for that. Okay. Next time I'll also show you how to do a foci segmentation and the nuclei, and then you give different labels for different foci for a particular nuclei, so that you can do all what we are doing in Scanner in ImageJ. Again, I would prefer that you do it in Scanner because there are so many other things. There's also one slide that I wanted to show you how to the comparison with the other softwares. So just roughly speaking, I mean briefly, that Imaris is good for visualization. So if you have a 3D data, if you want to do a tracking, cell tracking, I would still go for Imaris or Arrivis or other softwares. Okay. If you want to do a spot detection go for IC. IC is also kind of a software which also uses kind of an ImageJ backbone. There are so many other softwares, but about scanner, if you are doing a cell cycle analysis, DNA damage and other things, what we do in CPR, then I think scanner is a good option, because then you can do a lot of gating things. You can divide your populations, your cell cycle into different subcategories and do a lot of advanced level analysis, which in FIJI you cannot. So, yeah. So thank you so much.
Thank you.
Yeah, and I would be very happy if you just give me some response, because this is the first time we are conducting this workshop. And if you like me to carry on, then just let me know, okay? So we'll organize next time. Thank you so much.